Okay, this is 1.6 notes, modeling with equations. You will be able to use your calculator on this on your test or your quiz. A pasture is twice as long as it is wide. Its area is 115,200 square feet. How wide is this pasture? Okay, you can draw your rectangle so you know the width and the length is twice as wide. Well, we know the area. We know the length is 2W and we know the width. So we can go ahead and just multiply this out. And we know this is 2W squared. I would probably go ahead and divide here. This gives you 57,600. We've got W squared. I would take the square root of this. So we know that W is equal to 240. So the width would be 240 feet. Okay, on number 2, it says a manufacturer of soft drink advertises their orange soda is naturally flavored. Although it only contains 5% orange juice, a new federal regulation stipulates that to be called natural, a drink must contain at least 10% fruit juice. How much pure orange juice must their manufacturer add 900 gallons of orange juice to confirm the new regulation? Okay, I call this a mixture problem. So we've got a 5%, the mixture is a 10%, but we want to add pure orange juice. Okay, so this is what I would do. We're going to start with a 5%, but we want to add a pure orange juice, so that would be a 100%, the pure, and we want to get the mixture. The mixture is made up of 10%, okay? Okay, you definitely don't have to draw these boxes or do anything like this, but this is how I'm going to work this out. Kind of coming up with 2 equations here. Okay, so to start with the 5%, it says how much pure orange juice must be manufactured to add to the 9% of the orange soda. So the orange soda right here is this 5%. So we have a 900 of the orange soda. We don't know how much we're adding to get to the mixture. So this is what we're starting out with. Okay? So this is my first equation, just kind of a general equation to start out with. Then the next part is I'm going to go ahead and add in my percentages. So I have a 5% of my soda, my orange soda. Then I'm going to add my 100% orange juice. So 100% would be 1 to get my mixture here, and my mixture is 10%. Now I've got my 2 equations here. I think the easiest way is to go ahead and solve for y and plug this into your calculator. So this would be y1. So 900 plus x, and y2, I would divide that. So y2 would be 0.05. 900 plus x over the 10%. Plug that in and find your intersection. The intersection comes out to be 50 and 950. And if you need help finding that, I'd be happy to help you find the intersection. And it says how much pure orange juice needs to be added. And so that would be your X value. So that would be 50 gallons. Okay, it says what quantity of 60% acid solution must be mixed with a 30% solution to produce 300 milliliters of a 50% solution. So it looks like we have another mixture problem. Okay. Okay, so we've got to figure out what is the mixture. It looks like the 50% is the mixture. So we've got a 60% plus a 30% is going to the mixture, which is 50%. So So we don't know how much is the 60%. We don't know how much is the 30%, but we do know we're getting a 300%, a 300 milliliters of the 50%. Now we can add in our percentages. So this is 60% of the first one, 30% of the 30% mixture, and then the mixture is going to be 50%. Honestly, I would do a matrices on this, and if you need help on that, I would be happy to help you. I use the formula A raised to the -1 and B. I know there's some others. Use this in Algebra 2. It comes up with X is 200 and Y is 100. Again, you can solve for Y on both of these and plug them in and find your intersection. These are just set up really easy for matrices. And we're looking for the quantity of X. So that would be 200 milliliters of the 60% solution. Okay, looking at number 5, it says a jet flew from New York to Los Angeles with a distance of 4,200 kilometers. The speed for the return trip was 100 kilometers faster. So going from New York to Los Angeles, we could say was X. And going back, just say X plus 100. Okay? Then the outbound speed. If the total trip is 13 hours, so no matter what, it's 13 hours, what is the jet speed? All right, so what I'm looking at here is I am going to use distance equals rate times time. I'm going to solve for t, so this would be d over t. I'm sorry, d over r is equal to t. And I'm actually going to have two of these. Going to LA and going to New York. So my distance is 4,200 for both of them. My time is 13. Did not change. My return trip. So when I go to LA, it looks like my time or my rate is going to be X. When I go to New York, my rate is X plus 100. All right. The thing is I can't set these as two different equations. It says that my total trip was 13. So I'm going to set these as one equation. So I'm going to say 4,200 over X. And I'm going to add my second equation, which is 4,200 over X plus 100. I'm going to set that equal to 13 because it's my total trip is 13 hours. Speed is my X here. I guess I should have used R, but I didn't. So I need to solve for R. And again, we have our calculators, which is really nice. So what I can do is I can set this into Y1 into Y2. You can leave it as is. Put this into Y1, into Y2. If it makes you happier, you can move this 13 over and go ahead and find your zeros or your roots. When you solve this, you're going to get your X or your rate, which is what I should have put. This gives you 16 or 600, so this would be 600 kilometers per hour. And that's the speed of the plane. All right, our last one. Ornithologists have determined that some species of birds tend to avoid flights over large bodies of water during daylight hours because air generally rises over land and falls over water in the daytime, so flying over water requires more energy. The bird released from point A on an island 5 miles from B, the nearest point to straight shoreline. The bird flies from point C over shoreline, then flies along the shoreline to its nesting area D, as shown in the figure. So it either goes here, or it can fly over water and then go along the shoreline to D. Suppose the bird has 170 kilometers of energy reserved. It uses 10 kilometers a mile flying over land, so 10 over land, and 14 kilometers to fly over water. That's important. All right, so let's look at this. So if it takes 14 kilometers to fly over water here, it takes 10 kilometers to fly over land, but we only have 170 kilocalories of energy to fly in general. So we need to figure out some information. We've got 5 here. We've got a 12. So we need to figure out some information. How about we say this is x. Therefore, this would be 12 minus x. If I use Pythagorean, AC would be 25 plus x squared square root. So now we know this AC and this one, so we can go ahead and use an equation now. So let's look at A. If he's got a total of 170 kilocalories, let's set that equal to. If the bird is flying over land or over water here, and that takes 17, let's say 17 times this information. I'm sorry, not 17, 14. Sorry about that. So 14 times the square root of 25 plus x squared, plus it's going to take 10 kilocalories to go over land. So this is going to be 10 times 12 minus x. And let's see if he has enough kilocalories over land. We can set this in y1 and y2, or you can say minus 170 and find your roots that way. In fact, I think I'm going to do that this time. So I'm going to say this is 0 and go ahead and find my roots. I think it might be a little bit easier on this one. This is 10, 12 minus x. And I'm going to move my 170 out here just so I can find the roots. So this is y1 and this is y2. Okay, plug it into your calculator. Plug all this mess in at once. And let's find our roots. So finding your x values to see how many miles it actually takes. Okay? All right, so it looks like it's going to take 3.75 miles. And it's a repeating decimal, 67 miles. B says, did the bird have enough energy reserved to fly directly from A to D? So like this. Oh, that's a nice triangle. So from A to D, this would be 5. This would be 12. That would be 13. So to go from, that would be all over the water. So that would just be 13 times 14. Because that's his kilocalories. So that's 182 kilocalories. And he doesn't have enough because he only has 170 kilocalories to go all the way over land. So I would say no.